Now that we know what our inverse trig functions are doing and how we define them, let's take a moment and consider some practical examples. For example, Module 7 Investigation 10, problems 2 through 4 present us with this information. And they ask us what value is represented by the expression, and then using the circles, demonstrate the value of the expression, and then consider what value your calculator returns, and why does it return that particular value. Since we had to limit the range of each of these inverse functions, we have to consider the ramifications of that on practical examples. So let's take a look at this one first. So inverse sine of 0.25. Now remember, remember that that inverse sine of 0.25 should produce an angle, which means that what went into it here is this v over r that we defined earlier. And that's an important thing to keep in mind. So, excuse me, so what this problem is saying is that if we compare the vertical distance of the horizontal diameter with the radius, we get a ratio of 0.25. Well, on this first circle, this 0.25 would be easy to figure out because the radius of this first circle is 1, right? So we've got that radius of 1, which means that if v over 1 is 0.25, then just simply v is 0.25. Easy enough. So what we want to look for is all the places where the vertical distance above the horizontal diameter is positive 1. And if I look right here, it's positive 0.25. Positive 0.25 is here. And so if I just kind of run myself across here, I can find two places, one of them here and one of them here, where I have a vertical distance above the horizontal diameter of 0.25. Now, if I'm looking at that over here on this right-hand circle, that one has a radius of 5 rather than a radius of 1. So if I look at this, v over 5 is 0.25, then that means that v must be 1.25, right? Now, these are not drawn to scale, which is a little bit irritating, it's a little misleading, but 1.25 is about here. So if I draw my line across, here's a vertical distance of 1.25, and here's another one. And so again, I have 2 points along the pattern of the circle that are going to give me a vertical distance above the diameter, or the horizontal diameter that I'm looking for. So I'm looking for this angle, we'll call it alpha. And I'm also looking for this angle, and we'll call it beta. Same kind of thing over here. We're looking for alpha, and we're looking for beta. So visually, that's what we're looking for. So let's take a second, and in our calculators, let's just go ahead and calculate the inverse sine of 0.25. Now, in your graphing calculator, I don't have one on this particular computer, so I apologize for that. Although I do have Desmos. Let's try that. Let's use Desmos. Let's go here and here. Let's pull up Desmos. Come on. There he is. Let's pull up Desmos, and let's do come on. There we go. Let's do inverse sine. So we're going to, whoopsie, what are you doing? That's weird. Oh, weird. Huh. Okay. Let's try it one more time. I know what I'm doing now. There we go. Functions. Let's go inverse sine of 0.25. Okay. It gave me one angle. That's the angle that it gave me. That's it. That's all it gave me is this 0.2526 or 0.2527 rather. I'm in radian mode. Go away. I'm in radian mode, right? So that's the angle that I'm getting. So that's interesting. So let's go back over here and let's take a look at what that implies here. So when I found the inverse sine of 0.25, that gave me a single angle, and that angle was 0.2527. But I know that I should get two angles. So this 0.2527 is clearly going to be right in here because we know that that our angles that are in here, this should be pi over 2, which is definitely going to be more than this value. So alpha in both these cases is 0.2527, or approximately there. So the question is, what am I missing? How do I find beta given alpha? So looking at that, I have to realize that there's a reference angle over here. This guy right here, let's call him alpha prime, right? This little guy over here is also 0.2527. Well, if I look at that congruent reference angle that's over here in the second quadrant, I can figure out the larger angle that moves over that's coterminal with it by saying that beta then must be pi minus alpha. Okay, so let's go back over and type that in here. So if I use this same value, say pi minus that, right? So give me pi. Oh, you know what? I can type in pi. Let's go pi minus 0.2527. See? And I think maybe it doesn't like the fact that I have a capital letter on pi. That's very interesting. Whoa. There we go. All right. Let me go. Well, that's weird. Huh. It normally does. Oh, there it goes. Okay, so pi minus 0.2527 is 2.8889. 2.8889. So this is going to be 2.8889. So that's what's happening here. So when we ask ourselves what is inverse sine of this input value, this V over R ratio that we're supposed to be getting, we know that there are two angles that satisfy that, one in the first quadrant and one in the second quadrant, because we're just asking for a positive value above that vertical, horizontal diameter. But the calculator is only going to spit out one value. So if we apply ourselves to this question that we were asked over here, what value does your calculator return, and why does it return that particular value? The calculator is only going to return a single value because it doesn't really have a choice. So the calculator returns only the value from the range of the inverse function. So if we go back here and we look at the ranges of those inverse functions, remember we defined, there they are, the inverse function, we defined that inverse sine can only go from negative pi over 2 to pi over 2, which means if we have a problem that's asking us about the first and second quadrants, it can only return the value in the first quadrant, and we have to use what we know about the angles to figure out the value in the second quadrant. So let's apply ourselves to the second piece here, the cosine function. We've got inverse cosine of negative 0.75. So this negative 0.75 is h over r. And so we know h over r is going to be negative 0.75, which means in this first circle, we've got two values, one here and one here, that give us a vertical distance from the horizontal, horizontal distance from the vertical diameter of negative 0.75, because we were measuring to the right for positive values. And so we want this value, alpha, and this value, beta, right? And so we have to figure out how to do that. So the calculator is going to give us alpha. So it's going to give us inverse cosine. Let's go find that. Inverse cosine of negative 0.75. So let's make that happen. Inverse cosine of negative 0.75. There he is 2.4189. 2.4189. So we've got alpha is 2.4189. And And that means that beta is on the other side of pi from there, right? So this alpha that's right here is replicated, let's use a different color, is replicated here. You can think of this as alpha prime. This is a reference angle that would be equivalent. And so beta is not going to be pi minus alpha, it's going to be 2 pi minus alpha, because if I take all of beta and alpha prime, I should get a full 2 pi, a full rotation. So let's find that, 2 pi minus alpha. By the way, a little shortcut to this is just to go to the beginning of this guy and say 2 pi minus, and it takes us right in there. So 3.8643. So beta is 3.8643. Okay, cool. So that gives us those two values that we were looking for. And if we had done it over here in the radius 5 circle, it would have given us exactly the same values. So let's move down to the tangent and see what happens there. Now with this one, inverse tangent of 2. The 2 is meant to be a slope, right? And it's supposed to deliver an angle that has that slope. So if we want a slope of 2, okay, that's like rise over run, right? So 2 over 1. So if I go up 2 and over 1, if I start at the origin and go up 2 and over 1, up 2 and over 1, boom, boom. Same kind of thing, go back to, down 2 and back 1, right? That kind of thing. It's going to give me this kind of thing here. So we're going to have alpha, okay, and I'm going to have beta. It's maybe a little too dashed. I've got beta. So which one will we expect the calculator to deliver back to us? Well, we should expect alpha to come out because we know that the inverse tangent function has a range from negative pi over 2 to pi over 2, right there. And so we should expect to get the first quadrant angle out when we do that. So let's go over and find that first quadrant angle. So we're going to say inverse tangent. There's my inverse tangent of 2. Okay. So there's inverse tangent of 2, 1.1071. So alpha is 1.1071. Okay, which means that beta, all right, now the period of tangent is different from sine and cosine, right? So instead of comparing to 2 pi, really what we're doing is we're comparing from pi. But check it out, if I wing around like the space between here and here, this is pi every time. It doesn't matter where I draw this line. When I go from one ray to the opposite ray, the distance between them is pi. So if I want to find beta, the simplest way to do that is just to take alpha and add pi. Okay, so if I do that, do our little shortcut here, I'll take plus pi. There it is, go away, 4.2487. Awesome, so there we go. So to find that second angle, we have to apply what we know about the inverse functions and about the circle. So for inverse sine, we use pi minus the given angle to get the second angle. For cosine, we use 2 pi minus the given angle to get the second angle. And then for tangent, inverse tangent, we use pi plus the given angle to get the second angle. So there we go. So I'm going to let that be the end of it for this particular video. There's another problem in here, problem number 5, that follows right behind. That's a more practically, like a contextual example that you can work on. So, so I encourage you to take a look at problem number 5, where Savannah is sitting in this bucket of a Ferris wheel. So I can go back to the Ferris wheel problem, and it's moving counterclockwise, so it's moving in the positive direction. And we're looking for the measure of Savannah's angle of rotation when she's 42 feet above the horizontal diameter, the measure of Savannah's angle of rotation when she is negative 20 feet to the right of the vertical diameter, and consider the ramifications there. But for now, we'll call it quits. Thanks for watching.